Everyone, this is Karthik from CSEI, studying in Sri Venkateswara College of Engineering. Today our topic is solar space cooling of buildings. So we'll discuss about this in detail. So the introduction of solar space cooling is given here. Solar space cooling is a process that involves using solar energy to cool a building's interior. It's a process of cooling interiors of the building. It's an eco-friendly alternative to traditional air conditioning systems that rely on the non-renewable energy sources. Solar space cooling works by using a solar powered cooling system to absorb heat from the building's interior and to transfer it to outside. Here are some of the key components and techniques involved in the solar space cooling. So we will discuss about that clearly now. So solar collectors is one of the equipment. Solar collectors are the primary component of solar space cooling system. They absorb solar energy and convert it into heat, which is then used to power the cooling system. Absorption chillers. Absorption chillers are used in solar space cooling systems to provide the cooling effect. These chillers are refrigerant that absorbs heat from the building's interior and transfers to the outside. And the third one is thermal energy storage. Thermal energy storage systems are used to store excess solar energy for use during periods of low solar radiation. This ensures that the system can provide cooling even when there is little of no sunlight. Passive cooling techniques. Passive cooling techniques such as shading and natural ventilation can be used to reduce the amount of solar radiation that enters the building. This can help to reduce the amount of energy required to cool the building. And the last one is system controls. A solar space cooling system must be carefully controlled to ensure optimal performance that may involve the use of sensors and control systems that regulate the flow of heat and refrigerant. These are the methods and techniques. So the working structure. We will see the structure of solar space cooling of buildings. The system consists of two parts. It consists of two parts. First one is the solar collector and the storage, and the second one is the absorption, air condition, and the auxiliary heating. These are the two working structures or two things used in solar working structure. And the essential components of cooler are the first one is generator, second one is condenser, and third one is evaporator, and fourth one is absorber, and fifth one is heat exchanger. These are the essential components of cooler. And the block diagram is given, you can go through that. And you can see there is a pump and three-way valve, storage tank, solar collection arrays. So in the solar collection arrays the solar energy is stored, and the cooling water and cooling space, cooling water inlet, pump, and these are the components used in the solar space cooling of buildings. And the next one is working principle. How does it work? The principle of working. The operation of conditioners with energy from flat plate collector and storage systems is the most common approach to the solar cooling today. In essence, cooling is accomplished as the generator of the absorption cooler is supplied when the heat of a fluid pumped from the collection storage system or from auxiliary. Heat is supplied to a solution of refrigerant in absorbent in the generator, where refrigerant is distilled out of the absorbent fluid. The refrigerant is condensed and goes through a pressure reducing valve to the evaporator, where it operates and cools our water for the cooling space. This is the working principle of solar. The refrigerator vapor goes to the absorber, where it comes in contact with the solution, which is weak in refrigerant and which flows from the generator. The vapor is absorbed in the solution, which is then returned to the generator. The vapor is absorbed in the solution and then it is returned to the generator. The heat exchanger is used for sensible heat recovery and greatly improves cooler COP. For solar operation, there are two additional factors: the temperature required in the solar collector to drive the process, and the ratio of cooling produced to solar energy incident on the collector. These are the two additional factors. Pumping To more absorbent solution may be mechanical means or by vapor lift pumping in the generator for low pressure systems like LIBR H2O system require water cooling of absorber and condenser. The coolers used in most experiments to date are LIBR H2O machines, water cooled, lithium bromide H2O machines, water cooled absorber and condenser. The pressure in the condenser and generator is fixed largely by temperature drops across the heat transfer surfaces in the generator and condenser. The pressure in the evaporator and absorber is fixed by the temperature of the cooling fluid to the absorber and then by the temperature drops across the heat transfer surfaces in the evaporator and the absorber. Thus, to keep the generator temperatures within the limits imposed by the characteristics of the flat plate collector, the critical design factors and operational parameters include effectiveness of the heat exchangers and the coolant temperature. Common practice in solar experiments have been use water cooled absorbers condensers which in turn requires a cooling tower. This is a working principle of that, and you can see the diagram how this solar cooling of buildings works. The components are heat insulation, hot water tank, heat to house, and super window and heat exchanger. These are the things used in solar cooling of buildings, and this is all about solar cooling of buildings. If you like my video, please like, share, and subscribe. Thank you.